Commercial optical benches tend to be complicated and expensive, so I made this holder and ring system that can be cut with a laser cutter. The holes are threaded to take cap-head screws, and these stick to magnets embedded in the rings. This works pretty well. You can adjust the aim up, down, and left, right, and the ring doesn't slide around or fall off. These are easy to make. Snap together a few pieces, and a drill gun makes quick work of the threads. They cost very little and can be made by a high school or hackerspace or anyone that has access to a laser cutter. You'll need different rings for different components. This one holds a laser, this one a mirror, this one holds a microscope slide, and this one will hold a round lens in a range of sizes. This one has a mirror attached to a piezoelectric element for fine positioning using a DC voltage. We're designing holders for all sorts of components: prisms, filters, mirrors, lenses, and so on. Everything can be made with a laser cutter and some common hardware, so it should be easy to build up an experimenter's kit. We're also documenting a wide range of experiments you can do with this system. Simple demos for teaching basic principles, like basic optics, image projection, polarizers, and so on, and more sophisticated systems, such as this Michelson interferometer. You can see the fringes formed by the interference of two laser beams. One of the mirrors is mounted on a piezo element, so the fringes will move as the piezo voltage changes. The interferometer can measure very slight forces, so if you suspend a weight from the piezo mirror, you should be able to measure the gravitational attraction of the moon. So if you have access to a laser cutter, you should be able to build a kit of optical components that will let you do some pretty interesting experiments. Our system makes it easy to explore, experiment, and get a feel for how optics work.